So TruBeam is a really exciting technological advancement of material sciences, and it moves the ball forward from where we were with our existing extruded acrylic prismatic structures, which we've been using forever. And the fluorescent lamp, it was fine, but the problem with the LEDs now is they've shrunk so small that the optic itself also needs to shrink down to the similar ratio. And we've not been able to do that. And so TruBeam technology is essentially a shrinking down of those prismatic structures so small that you can only see them under magnification, which comes out to be about 50 times more structures in a given area than we had at our disposal before. And that is really helpful for us to create all of these different distributions that we would like to create. Because now we have 50 times the prismatic structures at our disposal. In theory, the distributions can be now much better, and in fact they are. And that's why we call it TruBeam, because it is really the idealized distributions that we're able to create with this. And the beauty of this is not only can we create better distributions, but we can also do so without the help of the reflector behind it. In our old scenario, we had to have a wall wash fixture that had a reflector off to the side with the LEDs canted off, aiming towards the wall, and that put light into the right area of the prismatic lens, which then did the rest of the work. But now, because I have 50 times as many prismatic structures, I don't need the reflector to do that work. All I need the reflector to do is get the light to the lens effectively, not lose any light, and the lens will do all of the work for us. And so now all of these lenses, we're able to create these distributions with the same exact fixture, which is super enabling. But the other thing, obviously, that we needed to do, because it's a family that we've created now, a 2 to a 5-inch product, 4 different apertures, we needed to create the same distributions across all 4 apertures. And TruBeam allows us to do that, again, by shrinking those number of prismatic structures down so small that I have exponentially more of them, allows us to do a much better job at every optic, but also at every aperture. And so what I'd like to do now is take you behind the curtain and show you how this actually works on one of our fixtures. Let's go look. Okay, so here we are in our light lab in Los Angeles. And what I have in front of me is our Bionic Pro 2 1.5-inch apertured product. And I wanted to use this one to show you because I have the least amount of real estate with the lens. It's the shallowest lens, and so controlling the light is the hardest out of the smallest aperture. And so now what we're looking at here is what's coming natively out of the fixture. I do not have the lens in. This is just coming out of the fixture. And so the first lens that I'm going to put in is our, what we would call just a satin acrylic. And what I want you to notice is how broad this distribution is, how wide this Lambertian distribution is, almost like a pumpkin shaped. And the reason for that is because we are not using the traditional extruded acrylic lens mechanism, which puts frost molecules into the material. Those frost molecules then have a tendency to knock down high-angle light, which in our case is not what we would like. We would like a much broader distribution, which allows fixtures to be put on wider centers, for one, so we use fewer fixtures. But secondly, it gives us higher foot candle values in this vertical plane, where people's faces are going to be, where an adjacent wall would going to be. This is what, when well building, ask for circadian vertical foot candles. That's what they're looking for, is something that can give me enough light way up high to light those vertical surfaces, again, people's faces or walls. And so this is our soft acrylic lens. Let me show you our batwing. Remember, this is a 1.5-inch apertured product, and so what you see immediately now jump to you is the main beams of the batwing itself, the main intensity, and how we have choked the middle and created almost a shadow effect here, so that when we get those hung in space, the resulting foot candle levels at the desktop are incredibly even. And because this has a 1.8 spacing criteria, we can get as far as 14 feet on center out of a 1.5-inch apertured product, which is really unknown in the industry today. Okay, so now I'm going to transition away from the symmetrics to the asymmetrics, and I'm going to use what we call our flat wall wash. And that has a main beam that aims only about 15 degrees from straight down, and it is a very tight beam, controlling how much light comes back up that wall so that the result is a very, very flat wall. Now, the beauty of these optics is that because it is optically controlled solely by the lens, I can flip it around and, of course, have that optic aim in the opposite direction. So there really is no misinstalling these fixtures. So the really great part of TruBeam is that it allows us to do multiple distributions within a given niche. And in this case, what I'm going to show you is another wall wash, but this one is what we call our focal glow. And to create that, we now have a main beam that raises up more towards a 30-degree angle, and we can feel how much softer it is right here, and that's what's going to give us this focal glow on the wall, this apparent brightness in a certain area of the wall. And the beauty of this particular optic as well, which is also an industry first, is again when I do the put it in the opposite direction, and obviously it goes the other way, now we're creating what we're going to call a perimeter fill, and this would be used in a corridor where the fixture might be wall mounted or recess mounted, and we want to light that whole corridor from just that one wall and head off in this direction. And so this is our perimeter fill as well as our wall wash glow. Okay, so we'll give you a little sneak peek of what's coming in 21, and that is our perimeter systems and our grazer optics. And here I'm going to use our wide grazer, which has a 30-degree beam. Also used as an industry first for pushing light all the way down to the floor when we're in large public open spaces with high ceilings that they want to use a linear product, and yet they need to push those foot candles all the way down to the floor. Something like this is perfect for that.